This is an Algebra 2 review on solving systems of linear equations using substitution or elimination. We're going to start with substitution. To use substitution, we want to solve one of the two equations for either x or y, and then we're going to substitute that expression into the other equation. Here's our first example. We're going to use substitution to solve the system 2x plus 5y equals negative 5 and x plus 3y equals 3. We want to choose one of these equations to solve for either x or y. We really would like to do it the easiest way, and so as I look at these two equations, the second equation is the easiest one to solve for the variable x. It involves only one step. So we're going to take this second equation and we're going to solve it for x by subtracting 3y from both sides of this equation. So subtracting 3y from both sides of the equation gives us x equals 3 minus 3y. Then we're going to take this expression for x and we're going to substitute it in for x in that first equation. So 2, instead of x now, we're going to replace it with 3 minus 3y plus 5y equals negative 5. Now we're going to distribute and solve. Notice our equation is only in the variable y. So distributing gives us 6 minus 6y plus 5y equals negative 5. Combining the like terms gives us 6 minus y equals negative 5. Subtracting 6 from both sides, negative y equals negative 11, and then dividing both sides by negative 1 gives us y equals 11. So we now have our value for y. We're going to take this value for y and we're going to substitute it back into one of the two equations that we started with, or a form of that equation. The easiest way to do that is to use the form x equals 3 minus 3y because it's already solved for x. So we're going to use x equals 3 minus 3 times our value for y. So 3 times 11. Substituting in, we have x equals 3 minus 33. So x is equal to negative 30. And we're going to write that solution as an ordered pair, negative 30, 11. That's using substitution. Sometimes it's not as easy to solve for one of the variables. You might end up dividing by 3 or 5, and you end up with different fractions, which are always harder to work with than integers. So there's also the method called elimination. In the elimination, the goal is to be able to add the two equations, and in doing so, it eliminates one of the variables. So we've got some steps to do to get there. The first step is to multiply one or both equations by a constant to obtain coefficients of one of the variables that differ only in sign. One would be positive and one negative. As we look at this system that we're going to be solving, I notice that the coefficients of x are 3 and 6. If I could somehow get this first equation coefficient of 3 to be a negative 6, then these two terms would add to 0. So what we're going to do is we're going to take this first equation and we're going to multiply it by negative 2. So let's do that. Negative 2 times 3x minus 7y. Make sure that you're multiplying negative 2 on both sides of the equation to keep the sides equivalent. So we end up with, by simplifying, negative 6x plus 14y equals negative 20. Now if I pair it with my second equation, I can go to step 2 and add the new equations because the variable x is going to be eliminated. So let's write our second equation below this transformed equation. And when we add those together, our negative 6x plus 6x add to 0. Our 14y plus negative 8y is 6y. And negative 20 plus 8 is negative 12. Now we have a very simple one-step equation to solve. Divide both sides by 6, and y is equal to -2. To find the value for x, all we need to do is put -2 in for y in one of the two original equations. So let's choose our first equation. We have 3x minus 7 multiplied by -2 is equal to 10. Simplifying, 3x plus 14 equals 10. Solving by subtracting 14 on both sides, 3x is equal to -4. And then dividing by 3 gives us x equals -4/3. So our solution is the ordered pair, -4/3, -2. Sometimes we have a solution that comes up a little bit unusual or a little bit strange. Let's take a look at this next system. We're going to solve it by elimination again. And again, if we look at the x's, we don't always have to look at the x's, but we are here. If we look at the x's, if I can get this first term, this 2x, to be -6x instead, these two terms would add to 0. So multiplying by -3 for our first equation. -3 on both sides of the equation. Simplifying gives us -6x plus 9y equals -12. And now we're going to pair it with the second equation. 6x minus 9y equals 8. We're going to add these two equations together. -6x and 6x again is 0. And gosh, look what happens here. 9y and -9y also add to 0. The left side of our equation is just 0. Adding our right side, -12 plus 8 gives us -4. We end up with the interesting equation, 0 equals -4. It does not equal -4. This is not a true statement. So since 0 does not equal -4 and never will, this system has no solution. The name of this system is called inconsistent. There's no point that they have in common. If we were to graph these two lines on a coordinate plane, we would find that these two lines would end up being parallel. Now let's look at a story problem involving solving a system of equations. Here we have a nut wholesaler who sells a mix of peanuts and cashews. The wholesaler charges $2.89 per pound for peanuts and $5.30 per pound for cashews. And the mix itself is to sell for $3.30 per pound. So how many pounds of each nut should be used to make 100 pounds of the mix? The easiest way, and the way that most often works for defining our variables, is to answer the question. So I'm going to answer the question, how many pounds of each nut should be used to make 100 pounds of the mix? Well, I'm going to need X pounds of peanuts. I don't know how many pounds, so I use the variable X. And I need to have Y pounds of cashews. Again, I don't know how many pounds of cashews, so I'm going to use the variable Y. Now I need to write some equations for these. First off, I know I need a total of 100 pounds. Well, if we have X pounds of peanuts and Y pounds of cashews, put them all together. That means add them together, X plus Y, and we have to have 100 pounds. So that gives us our first equation. The second equation is involving money, or how much our mixed nuts cost. So we see that the wholesaler charges $2.89 a pound for peanuts. So if we have X pounds of peanuts, the total cost of our peanuts is $2.89 times X pounds. We do the same thing for the cashews, $5.30 a pound for Y pounds of cashews. And these are all getting combined together, so let's add these two costs together. And those have to add the cost of the mix. Well, the mix is $3.30 a pound for a total of 100 pounds. So $3.30 a pound multiplied by 100 pounds. And now we have our second equation in our system. Simplifying the second equation, we have 289x plus 530y equals 330. Now we need to choose a method to solve this equation. And as we're looking at a method to solve this equation, I think substitution is going to work well in this case. So let's see how that works. Let's take our first equation here, and we can easily solve it for either x or y. So let's go ahead and solve it for x. So we have x plus y equals 100. If we subtract y from both sides, we get x equals negative y plus 100. And we're going to replace it with the x in this second equation. So we have 2.89 times negative y plus 100 plus 530y equals 330. Distributing, we have negative 289y plus 289 plus 530y is equal to 330. Combining these two terms, we end up with 2.41y is equal to, subtracting 289 from both sides, 41. Dividing both sides by 2.41, we get y is equal to 17.01, or to the nearest tenth, 17.0, and this is pounds of, it's y, so pounds of cashews. To find the pounds of peanuts, we're just going to take our value for y, substitute it back into one of our equations, and the equation that's already solved for x is the easiest one to use. So we have x equals negative y, so negative 17.0 plus 100 gives us x equals 83.0 pounds of peanuts. And that's a quick review of solving linear systems of equations.